From the book The Great Treatise on Astrology by Ciro Discepolo, Chapter 28, Precision in Calculations. I feel it's appropriate in a book like this to mention the precision in the calculations we use not only for drawing up a birth chart, but also for drawing up solar and lunar returns, primary directions, relocations, and more. On this subject, I must say, not all practitioners in the field have very clear ideas. And in my decades of passionate study of astrology, I've also heard and seen many rather strange and or curious things, such as the compilation of pseudo-correction tables for birth time relative to the months and days of the year, or discussions of alleged errors in one program compared to another, when, in those cases, it was quite obvious that whoever was doing them hadn't realized that the problem was entirely related to a different setting of the geographical data entered into the computer. To outline a general line of research, I would say that the object of contention should be divided into three different sections. 1. The problem of the calendar and the time of birth. 2. The problem of geographic coordinates. 3. The problem of the accuracy of the calculation engine, and here we will address them separately. Although we are within the framework of a treatise and not a guide, allow me to offer a brief review of the time of birth and the various expressions that describe it, which will help us avoid making a basic error we might regret. Francesco Maggiore's articles, more than one, published in the journal Ricerca 90, are very instructive. In them, the Palermo-born scholar traces the history of the computation of time over the centuries, up to the present day. The reader, approaching astrology for the first time, must be able to distinguish when we are talking about time. Astronomical hour. It is the 24th part of the average day and is counted from noon to noon rather than from midnight to midnight. Summertime, not to be confused with daylight saving time. It is the standard time applied by various countries during the summer to save energy, especially electricity. It was first adopted in Italy in 1916. Currently, European countries have established that it goes into effect simultaneously throughout Europe on the last Sunday in March and ends on the last Sunday in October. Unequal or planetary time, the 12th part of the time it takes for a planet to move from the ascendant to the descendant, or vice versa. Daylight saving time, the standard time applied throughout a country relative to the time zone. For example, when a news broadcast in Italy is broadcast at 8:30 p.m., it is the same time in both Turin and Bari, even though the two cities are about 40 minutes apart. In Bari, the sun rises about 40 minutes earlier than in the Piedmont capital. Therefore, it is a false time to govern national train management systems, radio and television broadcasts, etc. Local time corresponds to the actual transit of the sun at noon in a given location. In Italy, only the local time in Catania, which lies exactly on the Central European meridian, corresponds to daylight saving time. All other cities have a different local time that must be calculated to construct a chart including house numbers. In my new guide to astrology published by Armenia, I've included a simplified graphical method, the three-line graphical method, that allows you to easily calculate the local time for any city in the world, sidereal time. This is the time given in the ephemeris for 0000 or 120000. It represents the 24th part of the sidereal day. True time. This represents the 24th part of the true day, indicated by two successive transits of the sun at noon over the local meridian. It is therefore quite clear that even a mistake in applying the above rules will result in a completely incorrect construction of a celestial chart. Let's take a few examples from Italy. If we draw up a natal chart for a birth that occurred in, say, 1850, we must remember that at that time clocks showed local time, that is, based on the actual passage of the sun at noon in the locality. Since today we proceed almost exclusively via computers, this means that if we were born in Fiesole, we will store a Fiesolev in our computer city database, where the final V stands for old. We will store it, taking care to enter the same value as the geographic longitude as the time zone. This way the computer will calculate precisely, and we will no longer witness, as in the past, long and pointless online debates over alleged calculation errors by one software program compared to another. Let's stay with Italy and remember that from the autumn of 1866 until November 1st, 1893, our peninsula was divided into three parts. The continental part adopted en masse Rome time, longitude about 50 minutes east of Greenwich, the London observatory that is universally accepted as the international reference point for calculating time. The Sicilian part referred to Palermo time, and the Sardinian part to Cagliari time. From 1893 onwards, all of Italy agreed to place itself under the first time zone east of Greenwich, the one passing through Görlitz, Saxony, and also through Catania. Starting in 1916, again in Italy, summertime was instituted, a legal expedient to save energy, especially electricity. This complicated the situation considerably, so much so that when I began studying astrology in 1970, the leading astrologers of the time were unaware that summertime had even been in effect in 1948. Federico Caponi in particular, but also myself and other scholars, then compiled a table still used in Italy based on a careful reading of the official gazettes of the time, verified in turn by reading the newspapers in newspaper libraries, which, on the day of its start and the day of its end, precisely indicated year by year the application of summertime in our country. But the problem doesn't end there, and there are many exceptions. For example, few colleagues are well versed in the history of the summer of 1944, when daylight saving time was implemented in Italy, with a difference of about a week between North and South, due to a violent partisan and liberation battle that took place near the so-called Gothic Line. We must also remember the issue of the calendar in its transition from Julian to Gregorian. The first major revolution in the calendar was due to Julius Caesar, who introduced his own calendar, called Julian, in which the year consisted of 365 days, and 1 year in 4 consisted of 366 days, a leap year. However, since the actual year is shorter than the theoretical one, 365 days 5 hours and 48 minutes versus 365 days and 6 hours, it results in a delay of 3.09 days every 400 years. The accumulation of this error, as Federico Capone thoroughly explains in my book Ephemeris, 1582 to 1699, edited by him, was corrected by Pope Gregory XIII in 1582, Gregorian Reform. He began by recovering the accumulated delay since the time of Caesar, by removing 10 days from the calendar in order to move the equinox back to March 21st. It was therefore established that the day following Thursday, October 4th, 1582, was Friday, October 15th. Subsequently, the remaining 3 days were eliminated, establishing that the secular years, 1700, 1800, and 1900, although multiples of 4, i.e. leap years. The year 2000, however, was a leap year. This calendar, although much more satisfactory than the previous one, was not adopted simultaneously by all countries. The astrologer must therefore know the timing of its adoption. There are specialized texts that provide time regimes from around the world, including the assignment of a particular time zone, which can change over the years for political reasons. Some of these texts are riddled with errors. The most authoritative on the subject are Thomas Shank's Atlas and Henri Le Corre's Régimes horaires, published by Traditionnel. But the Bible of the subject, allow me this small presumption, which cost me and 5 or 6 other scholars and IT specialists almost 4 years of intense work, is certainly a magnificent software program produced by the author, both in standalone form for personal computers and available free online at http://www.cirodiscepolo.de horoscopy only. It is essentially a massive database of 3 million cities whose longitude and latitude have been detected by satellite with absolute precision. The corresponding time regimes for each city have been studied from Roman times to the present day, taking into account the various changes related to the Gregorian reform, the application of local time, daylight saving time, and summertime. For a more comprehensive discussion on this topic, I refer you to the following links: www.cirodiscepolo.it/enormedatabase.pdf and www.cirodiscepolo.it/enormedatabase2.pdf. Now, let's think for a moment about the problem of geographic coordinates. As you all know, for the correct construction of a natal chart, or a solar return, lunar return, etc., it is essential to establish the precise location of a birth or return. Here on Earth, to establish this parameter, we use geographic coordinates, longitude and latitude. Longitude can be expressed in both degrees and hours. For example, 15 degrees corresponds to 1 hour, 7.5 degrees to half an hour, and so on. So the 360 degrees of the circumference of each parallel correspond obviously to 24 hours, while latitude is expressed exclusively in degrees. These are fairly simple concepts, yet even today, December 12, 2002, we still find ourselves reading, even on major websites, the following advice to navigators. Enter the latitude of your birthplace, for example, 103.50 north, SIC. The expression of astonishment is justified by the fact that geographic latitude cannot exceed 90 degrees, either north or south, with a value of 0 degrees at the equator and 90 degrees at the poles. It goes without saying that if we enter inaccurate or different geographic coordinates, the results of the celestial map calculations will be equally different. In this regard, consider that the city of Los Angeles covers an area of approximately 200 kilometers, roughly the distance between Rome and Naples. Therefore, it's obvious that if I enter the geographic data for Los Angeles, say from one end of the Californian megalopolis, I'll get certain values for the ascendant and midheaven, and completely different values if I enter the geographic coordinates from the opposite end. But to what extent does such a variable affect the situation? Here's a simple calculation that serves as a general example of what we're discussing. Let's start with the Earth's equatorial radius, which, as we know, is 6,378.163 kilometers, since the circumference of a circle is 2 multiplied by pi, and the radius r It follows that the circumference of the Earth at the equator measures 40,075.180 kilometers. Since the circumference is equal to 360 degrees, we derive the following proportion. 40,075.180 kilometers are to 360 degrees, as 1 kilometer is to x degrees, from which we obtain that 40,075.180 kilometers is to 1,296,000 seconds of a degree, as 1 kilometer is to x seconds of a degree, and consequently that 32.339 seconds correspond to 1 kilometer. This means that the difference of 1 kilometer at the equator corresponds to approximately half of a minute of a degree of geographic longitude. In other words, if a location in a database is listed as having a longitude of 14.25 east or 14.26 east, it's not an error, but simply a different location, since each city extends for several kilometers, as I wrote earlier regarding Los Angeles. Finally, let's say a few words about the accuracy of the calculation engine. Anyone who has ever attempted to program computer calculation routines for constructing a natal chart, today or in the past, I believe started, like me, with Michel Erlewin's excellent book, Manual of Computer Programming for Astrologers, American Federation of Astrologers, Tempe, Arizona, 1980, pages 215. It contains the calculation algorithms and even the program steps in a first-generation basic language useful for the purpose. However, anyone wishing to develop their own software based on this starting platform would find it more or less a fun game for calculating the ascendant with a certain approximation. To obtain highly precise longitudes, however, years of continuous refinements are needed to improve the precision of the parameters used for the calculations. In recent years, the author, together with Luigi Miele, had developed their own calculation engine that ensured remarkable precision, very close to that of NASA's Ephemeridis or the American NOVA software, even for centuries past. However, it is possible to verify that there are even so-called professional software on the market that not only get the degrees wrong, but sometimes even the signs in the positioning of the stars in past centuries. In the latest version of our programs, however, we relied on a search engine much more precise than our own, developed by Swiss Ephemeris of Zurich. With it, it is possible to achieve a precision equal to 1/10,000th of a second, the fourth decimal place after the second degree, in the time interval from 8000 BC to 8000 AD. It would be pointless to specify this, but since there's always someone at the top of the class who raises their hand, we'll say that, obviously, this precision applies to the current period and decreases proportionally as we move away by centuries or millennia from today's dates. At this point, I think we have established some general precision criteria that can at least allow us to define it in astrological calculations. There are other variables that we haven't considered, but which can be considered less important than those described in this chapter. Note as of August 2025. Currently, the old astral software from the 1980s, later replaced by the more precise Aladino from the early third millennium, was implemented by myself and the excellent computer scientist Stefano Briganti, and is hosted on the myastral.org platform in Dubai, owned by Chiara Barbaro. Regarding this software, I would like to point out that not only does it calculate solar returns and lunar returns, with the same longitude as the natal sun or moon, thus ensuring accuracy down to the 10,000th of a second of a degree. But, and this is certainly even more important, it can domify without errors. With Placidus, even at very high geographic latitudes, a crucial feature to avoid placing one or another star in the return sky in the wrong house. Last but not least, I would also like to point out that with these two exceptional starting precisions, it was possible to implement the exact place of birth or return function in every calculation, meaning, for example, that it is possible to also indicate the precise point of a hospital room where a child was born. This is not, as some might think, a dream or a fantasy of power, but a real practical need for precision if we are referring to places very far north in the world.